In this session, I would like to refresh Truss Analysis using Stiffness Method. Okay, in Truss, remember the degree of freedom is equal to 2 at each node. Okay, in X and in Y, X and Y direction. X and Y direction. So basically, if we have truss, like this, so there are 1, 2, 3, 4. There are 4 nodes. And we have here how many elements? Element number 1. Okay, element number 1, element number 2, element number 3, element number 4, element number 5. So there are 5 elements. Okay, we have 5 elements. 4 nodes, 5 elements. Let's say this truss is subjected to loading. Okay, loading, horizontal load and vertical load. Okay, this one 200 kilonewton and 150 kilonewton. Okay, so the distance from 1 to 4 is actually like this and this. Okay, this is about 3 meter, as well as this one is 5 meter. Okay, then what we need to put here besides all this is the arrow. Okay, the arrow. Okay, arrow put in any direction that we like. The arrow, and then the coordinate. We need to put the coordinate. Okay, we put the coordinate. At node number 1 is 0, 0. Node number 4, node number 4 is 6, 0, 6, 0. At number 3, 6, 5, 6, 5. And node number 2 is 3 and 5. 3 and 5. Okay, if we sketch the diagram according to unconstrained and constrained, okay, look at the support. So there are 5 unknown reaction. There are 5 unknown reaction. 2 at 1, 2 at 1, 2 at 3, and 1 at 4. 1 at 4. So we have 5 degree of freedom, representing 5 unknown reaction. Okay, so total must be 8. Total must be 8 because 8 come from 4 times 2. So 5 have been put in constraint system, so there are remaining 3. So it has 3 DOF representing 3 unknown displacement. Okay, so we should label Okay, we should label, put the label. Okay, so for the reaction, 1, 2, 3, 4, 5, 6, 6, 7, 8. Okay, and then we put the blue for unconstrained. Okay, it is 1, 2, 3. Okay. So for element global stiffness matrices, element global stiffness matrices we have 5K. Okay, we will have 5K. Okay, we will get K1, K2, K3, K4, because there are 5 elements, right? This is K5. Okay, for K1 the label is 4512. 4512. It is 4512, 4512. Okay, for element number 2 is 454536. It is 44536, 4536. Element number 2. Element number 3 is 121236. 1236. 1236. It is 1236, 1236. And then 4, it is 3678. 3678. It is 3678, 3678. And lastly, element number 5 is 1278. It is 1278, 1278. Okay, this is all element global stiffness matrices. Okay, so if we want to consider, let's say we want to consider the temperature changes. Okay, let's say we want to consider the temperature changes. Okay, consider temperature changes. Okay, consider temperature changes. Okay, let's say like this, we have table. Okay, member delta T. Delta T. Delta T has the unit in degrees Celsius. Okay, member and delta T. Okay, let's say there are few member affected. Let's say member 1, member 2, member 3. Okay, let's say member 1, member 1, member 1, member 2, member 3. Member 1, 60. Member 2, negative 40. Negative 40. And member 3, positive 50. Okay, so member 4, 500. Okay, normally the effect of temperature sentence. This is just to show you if we have more than one member get the effect of temperature. However, this is not the real condition lah, because in real condition, due to temperature changes, it will also always affect the whole system. Okay, so what we need to do is when we have effect of temperature or fabrication error, it means that we have to consider Q naught and this in the system. Okay, because temperature changes as well as fabrication error will be affected the element. Dia akan affect element. So all this affect element. So we need to establish Q naught for each element. So for Q naught we will have Q naught 1. Okay, Q naught 1, remember that we need to produce 4 values. 4 values it is temperature, it is AE, alpha, delta T. AE, alpha, delta T times with Cx, Cy, negative Cx, negative Cy. Okay, we check back. AE, the unit is in kilonewton. Okay, the unit is in kilonewton. Alpha, the unit is per degree Celsius. Ini per degree Celsius. Delta T, the unit is degree Celsius. And Cx, Cy, no unit. Okay, so we will have Q naught 1, where the position is equal with K1 4512. Okay, then we will establish using the same Q2 naught. Okay, of course, AE will be given in the question. AE and alpha will be given in the question. Okay, so we will get Q2 naught, Q3 naught. Okay, Q4 naught, Q5 naught. You don't write into this, doesn't matter because the value is all 0. So yang ni Q2 naught 4536. This is 4536 as well as 1236. So 1236. So whenever you want to calculate the Q naught capital, so Q naught capital is equal to Q naught 1 plus Q naught 2 plus Q naught 3 plus Q naught 4 plus Q naught 5. And if the question just asking you to calculate unknown displacement, means that we need only up to 3 unknown displacement, because there are 3 unknown displacement. Here 3 unknown displacement. 3 unknown displacement means that we need to establish Q naught, okay, for 1, 2, for 2 and 3 position. Okay, 3 position. We get from Q naught 1, Q naught 2, Q naught 3. So for value number 1, this is value number 1. For value number 2, this is value number 2. Alright, for number 3, this is 3 and 3 here. So all together we plus, and that we will get this. Okay, we will get Q naught. Q naught. So the stiffness equation okay, will equal to Q is equal to KD plus Q naught. Remember this one for truss. Okay, it comes from temperature changes and or fabrication error. So Q naught will be put into this whenever the truss has the effect of temperature changes and fabrication error. Without that, we don't have to consider Q naught because Q naught is equivalent to 0. Okay, so once you have this, as usual, we will write the stiffness equation. Q is equal to KD. Q minus Q naught is equal to K as well as D. We have 3 unknown, right, just now. D1, D2, D3. And then we will solve for D value. Okay, in this case it is rotation. Okay, so this is how we want to include the effect of temperature changes. Okay, for fabrication error, the step is the same. Okay, like what I have shown to you in this video, except the formula is different. Okay, the formula is different because we want to have the Q naught due to temperature fabrication error. This is due to this. If it is due to fabrication error, it is Q1 naught is equal to AE delta L over L times with Cx Cy negative Cx negative Cy. Again, you will get the value based on the K label. Okay, K label 4512. Okay, it is 4512. Okay, I think that's all for discussion today. So, Assalamualaikum warahmatullahi wabarakatuh.